In this video, we are going to talk about arc length. Now, I strongly recommend that you watch the next video right after this and take notes on it, because we're going to talk about area of a sector. And it's really useful with my analogy of this situation to talk about both of these at the same time. So this first video is going to be about arc length, and the second video is going to be about the area of a sector. And you'll see once you've watched that video how these two are related. So first, we've got a big sentence to unpack. I'm going to try to translate this to you after I get done reading it once. In the following, S denotes the length of the arc of a circle of radius r subtended by the central angle theta. Ooh, okay, what does that mean? Well, first of all, let's draw a circle. Now, what we have is we have S, which denotes the length of the arc of a circle. So starting at 0 degrees, we're going to have a certain distance from here to here, and we're just going to call that distance S. That happens to be our arc length. But another way to think of the arc length is to think of it as crust. So think of a pizza. The crust is the arc length of the circle. Now, this would be an infinitely thin layer of crust, because this would be the distance along the very outer edge. It wouldn't actually be part of the crust that you would eat. It would be the distance of that crust. But let's just, for the moment, think of it like a crust. And then let's unpack the rest of this, because S denotes the length of the crust of radius r. Okay, so we're on this circle with radius r, so here's radius r, which also happens to be this distance here as well, because we're traveling from the circle, subtended by the central angle theta. Subtended is another way of saying created by this and theta, and the book is going to use the letter T here, although theta, starts with the letter T, so you can interchange those. So that's what this means. If you know your angle theta, or T, and then you multiply that by your radius, then you get your arc length. So your arc length formula is going to be S is equal to the radius times theta, and this theta has to be in radians. The R stands for the radius. The R is the radius. The theta is in radians. So let's look at a 12-inch pizza. Now, I'm talking about problem 15. It's a 12-inch pizza. Now you might say, what do you mean? I see the R equals 6. Don't you mean 6-inch pizza? No, I don't actually, because when you get a pizza, they always give you the pizza in terms of its diameter. The diameter is the distance across, or two radius measurements. So let's now take a look at this picture here. So if we have a 12-inch pizza, so it's 12 inches across, okay? And then we know that the radius is 6 inches. We also know our theta is 2 radians. So we learned in the previous video that a radian was about 57.3 degrees. And so 57 times 2 is about 120, probably a little shy of that. So it's about this much here. So this is my theta, or T, if you want to use the lowercase letter t like the book does. Well, we're now trying to figure out our letter S. So we plug in our formula here. S equals r times theta. So to find S, we multiply by our r, which is 6, times our theta, which is 2. And since this is in radians, we can just say that our S is equal to 12 inches. That is the little double tick mark there. It's the symbol for inches. So we get a roughly 12 inches of crust, or the distance of the crust would be 12 inches along the outer rim of the pizza if we ate roughly about 120 degrees of the pizza. So you get a foot-long breadstick with that. Okay, so for the next three problems, this one leans into a picture pretty well, because what we have is we have a circle. We have our unknown radius. We don't know how big that radius is, but we do know we have a quarter radian. Now, a quarter radian is a fourth of 57.3 degrees. So half of 57.3 is about 30. Half of 30 is about 15. So this is a really skinny mini piece right here. So this is a skinny piece, 15 degrees. Not too big. Now, we know that this distance from here to here is 6 centimeters. So 6 centimeters. So our formula is going to look like this. Our S is equal to R times theta. What we know is we know that the S is 6. We don't know the radius, but we do know that the theta is 1/4. We can convert that into a decimal if we wanted to. We can say R times 0.25 and divide both sides by 0.25. Or I could just multiply by its reciprocal, 4/1 on both sides. Anything you do to one side of the equation, you do to the other. And 1/4 times 4/1 simplifies to 1. So what we have here is R. Then we have 4/1 times 6, so top times top, bottom times bottom. And so the answer is 24/1, which is 24. So our radius is 24 centimeters. That is our answer for problem 16. Okay, so problem number 17 does not lend itself to a picture because what we have is we have this radius, which is 6 meters. And we have this, crust, which is 8 meters. But again, we don't know how far to draw it because we don't know theta right here. So what we're going to do is we're going to fill in the picture after we get done with the problem. So we have S equals R times theta. What we'll do is we'll plug in numbers that we know here. So the S is equal to 8, and the R is equal to 6, and the theta is unknown. We divide both sides by 6, and 8/6 is left on one side, and theta is left on the other. Now 8/6 is reducible to 4/3, which is reducible to 1.333, and it keeps going and going and going. And since we're rounding to 3 decimal places, this is 1.333 radians. So our answer is 1.333 radians, which is roughly 1.333 times 57.3. So you'd have to take that and calculate it on your calculator. That would be for the best results here. And I quickly type that in to get a roughly 76.4 degrees. So it's under 90, but that's okay. That's okay. And since it's under 90, what I can do is just kind of fix the, there you go. So that's about the size of your picture right there. That's roughly about 1.333 radians for my theta right there. 1.333 radians for t. Okay, so our final problem here for the video is to do this problem. It seems very straightforward because, look, it gives you the radius. Like, oh, awesome, it gives me the radius. So the radius is 3 meters. Okay, now it gives me theta, which is 120 degrees. Awesome, I can go 120 degrees right there. Find S. Oh man, I love this. This is S equals the R times theta. So if you do this problem and go 3 times 120 and try entering that as your answer, you'll be wrong. Because the 120 degrees is in degrees. It's not in radians. And every other problem that we've had so far here, the theta has been in radians. So since this is in degrees, we got to do a little conversion. So take that 120 degrees and multiply it by pi over 180. Okay? And doing so, this is going to give you a cool answer here. I got to tell you. So what happens is that the 3 times 180, or 3 times 120 divided by 180, this numerator here, 3 times 120 is 360. 3 times 120 is 360. And 360 divided by 180 is 2. So again, you get an answer of 2 pi. So that's approximately 6.28 meters. So this S is equal to 6.28 meters. All right? That is the decimal approximation of how much crust you have. And I know you might be thinking like, oh, 2 pi is 2 spins around the circle. It is, but we're not on the unit circle here. We are now looking at a distance in terms of radians, and we have just made that into a measurement with meters, and we did it. That is our 6.28 meters. So, in review of this problem, the radius was 3. The degrees were 120 degrees, but we took that 120 degrees and we multiplied it by pi over 180. In doing so, now we have 3 times 120, which is 360, divided by 180, which happens to be 2. And the pi is there. 2 times pi is 6.28. Our units are in meters, and the distance of that arc is 6.28 meters. Thanks for watching. And again, I strongly recommend that you stick with these videos and go to the sector area, which we will talk about in the next video.